Good afternoon, everyone. I'm Dan Avila from enVista, and I'll take just a couple minutes to introduce you to who enVista is so you get a little context of where we're coming from. enVista is a mid-sized consulting firm based out of Indianapolis. We do four things. Number one, we're supply chain consultants. Think of us as end-to-end. We do everything from supply chain network strategy to inventory optimization, supply chain planning, distribution center design, distribution center optimization. Then we do supply chain software selection. Think of WMS, warehouse management systems, labor management systems, and transportation management systems. The third thing is we're a design build firm, meaning we are putting in all of this automation you see out there as a turnkey contractor. So you contract with us, we'll put this all in for you, integrate it, make sure it works, test, train, debug, and make sure everything is working appropriately. And finally, we are a Microsoft D365 and Business Central implementer. That's a little different, right, for most consulting firms, but that's a company we acquired years ago, and we do that type of business. Introductions, I'll go first. I'm Dan Avila, Vice President of Consulting and Automation for enVista. I handle a lot of the commercial responsibilities for enVista. Been doing this for about 30 years, and I've had the pleasure of working with some great clients over the years. Currently doing some very, very neat projects looking at this type of automation that you see out there. And one of the big things that we do is we help our clients shepherd them through the process of automation, what to automate, how to justify automation, and more importantly, how to get your board of directors to approve the project, okay? Because if that doesn't happen, you go nowhere. Okay, next is Dean Starovoznik.
Hey, I'm Dean Starovoznik. I'm a client partner with enVista, and I view my role primarily as an educator, helping the decision makers of our clients understand the solutions we might be considering, why they may be a good idea or why they may not be, kind of like what we're talking about today, and help them make really good decisions for what's best for their firm.
Over to me. Hello, everybody. I am Trevor Howard, a senior director within our strategic DC design practice. About 25 years of experience doing these types of automation projects, and I've got a team of individuals that help kind of come in and do the front end business consulting to try and drive the smart decisions on automation for our clients.
Okay, let's talk a little bit about what we're going to cover today specifically. So I'm going to turn it over to Dean here in a moment, and he's going to talk about what is driving the demand for automation. So we've been talking about it for years, but it's labor, it's throughput, it's capacity, it's space. So Dean will talk about all those subjects. And then how has automation evolved? So I've been coming to this show, or a form of this show, for about 5 years now. None of this existed 15 years ago, very little 10 years ago, but it has exploded, the amount of technology. So we'll talk a little bit about how things have evolved. And then we'll turn it over to Trevor, who will talk about how automation is justified. So we'll go through a real case study of how we justify automation, and we'll talk about the process that we shepherd our clients through to go from what I call the Flintstones to the Jetsons, okay? And that's really what we're talking about here. And then finally, Trevor will wrap up with when should automation be implemented and how. So that's our discussion for today. And with that, I'll turn it over to Dean.
You guys can't, oh, there we are, good. So we're going to talk a little bit about some of the macroeconomics that are in flight right now that are driving automation demand, and some of those are changing. Some of you may not realize these slides had to be submitted at the end of November. So some of the economic data you're going to see on my slides is a little bit dated. I'm going to help you understand some of the current things that are different than they were 3-4 months ago, okay? So first off, obviously e-commerce is a big part of what's driving the demand for automation. And when you're talking about e-commerce, what you're basically doing is paying somebody else to walk the aisles of the store, get the product for you, and deliver it to your house. All of which, of course, has a cost, and minimizing that cost with tools like automation is part of what's creating this issue. And e-commerce, no surprise, has been growing rather rapidly. This is one of those charts, though, that's a little out of date. As of, this was November of last year, you can see that the percentage of retail sales that were e-commerce peaked in 2020, no surprise with the pandemic, got to be, 17.8 and grew rapidly. The projections were that it would come down to 16.8% in terms of growth as a percentage of retail sales, moving it up to 19.6. The actual growth of e-commerce as a percentage of retail sales was only 6% in 22, and only 3% projected for 23. So quite a lot different than even November of last year was expecting. Part of why we're seeing a little bit of a slowdown, not even necessarily a slowdown, but a slowing of the growth in what's happening in our world today from an automation perspective. However, the labor situation really has not changed. Again, this is data from late 22. At this point today, 10.8 million jobs remain unfilled, with only 5.2 million people in theory available for those jobs. So a big disconnect between labor demand and labor availability, again, driving the demand for automation. As well, the cost of that labor has gone up pretty substantially. You can see here we're seeing in 21, roughly 48,000 for an average warehouse worker. Now we're seeing 54 in 22. And that remains roughly similar today, 6 months after this data was relevant. So the cost of the labor as well as its availability have both gone in the right direction for automation, but it make it more difficult to operate a facility with that labor. As well though, and it's the case in most automation ROIs, space is a major consideration. And space is also more of a challenge today than it was. Now this is becoming a little less of an issue because there is a lot of construction went on the last couple of years and demand didn't quite grow quite as quickly, certainly in the last few months. So we're seeing that the inventory availability is a little bit easier, but it isn't as easy as it was 5 years ago, and the cost is certainly still much higher. And that's true regardless of where you are. Of course, here in Chicago it's a lot more expensive than it is in Joliet, than it is in Peoria, but all of those have gone up comparably as we're showing here in this graph. So labor and space, the demand for that activity are all still working in the favor of automation, though maybe not quite as much. So for example, today we're seeing that a board of directors may be a little bit slower to approve an investment, even when the justification is pretty attractive. And so it's an issue where they need to recognize where their capital is going and whether or not the income for them, their firm is going to be reliable and be comfortable with those things before they'll make the investment. All right, but for the most part, the leadership in our client spaces are still saying they need automation. And by the way, this presentation will be available on the DC Velocity site, so take pictures if you wish, but you'll be able to get a lot cleaner pictures from the website here in a little bit. Those lines that you see in green are investments that are automation oriented, where our clients' leaders are saying we're going to need this kind of automation. So over a third of all those are areas where we expect to see automation being a big part of their initiatives throughout their operations, not just in the warehouse. All right, so what is automation? You know, walk around the floor for 5 minutes and you can answer that question pretty readily, and so I'm not going to try to do a lot of that, but I did want to just touch on a few things that have been going on to understand what's really happening. First off, to Dan's point, when I came here in 1995 for the first time, I'm older than Dan, by the way, because I spent 10 years on big gray boats before coming into this industry. We could see carousels. We had AGVs, right? We had robotic arms picking cases off of pallets. And in fact, that ASRS on the far right is almost as old as I am. There's a Kellogg's pallet storage device that was basically an automated storage device that's nearly 60 years old. So automation has been around for quite some time, but what we're seeing is some form of robotics in much of what we're doing today. And I've divided these kind of conveniently up into 4 quadrants, where it's goods to person or person to goods, robots to goods, or goods to robot. So it helps categorize kind of the different options. And each of these has a play and a place, an application, depending on your circumstances. So just to explain these a little bit, what are goods to person? On the left, we see Kiva, the orange bot, back in 2007 became Amazon Robotics. But here we're bringing a shelving unit to the person. The operator walks only the distance between the shelving unit and their put location, the tote on the left. And on the right is a goods to person station, which could be associated with any of the goods to person devices here, whether it's a cube, an aisle, a shelving unit that provides a tote to the operator as well as presents a destination tote into which they can pick. So the operator stands one place, the goods come to them, right? Pretty simple. Person to goods involving robotics involve a couple different options. In the follow me, the cart is automated and it takes the operator to the pick locations. It provides information about what to pick, what order to put the item in, and then takes those orders to packing and the operator picks up another cart. You see this in manufacturers like Six Rivers and so forth that'll do this kind of work. The follow you is where the operator is actually driving the tote to come along with them, and when they're done, it can go off to packing. This is a little more older model because it relies on the operator a little more to control the pick path. And then finally, the find me, this would fall into, say, the locust type of a robot where it goes and waits for you to find it and that it needs somebody to pick the item off the shelf and put it in the tote so it can go off to the next pick, okay? And at any point, if you have a question about some of this, if I went over it way too fast, that's fine. Just holler out or something. We can get the mic in front of you and answer the question. So now, robots to goods is a little bit more bleeding edge. That's moving a robot to the product and having the robot do the picking, right? So something like a Boston Dynamics here on the right side of the slide, where that robot's actually going to go and pick the case up from a pallet. These are still early days and mostly at a beta level for anything that's in real operations. There's a lot of challenges here. People walk and pick much more readily, and there's a lot of complicated situations in a real warehouse that these sort of devices run into. But it is up and coming. It does have some promise. And then finally, goods to robots, where there's no human really involved in any of the activity here, whether we're bringing product, in the case on the item on the left, inside those little circular devices, there's a robotic arm picking an item up off of a bulk pile that gets dumped in with a conveyor, identifying it, and then putting it in the right order. Those orders are arrayed around the outside. It's a robotic put wall. And on the left, on the right, we have a goods to robot bin pick operation. And you can see examples of this, say at the Bastion booth and so forth, where they've got a robot picking items out of a bin that's presented by like an auto store, as we show here. So those kind of categories, as you see, all of those basically address the picking function. Why so much effort in that area? This is usually where the largest number of people are involved in the warehouse in any one function. And so if we focus on this first, we have the biggest bang for our buck, right? And so the PE money is going to these firms. The investment by the clients in these automation options is the greatest because the return on investment is easiest usually. There are a number of others, but these tend to be the ones where we see the most focus. You'll see a few more in Trevor's case study as well. All right, so Trevor, we've given you, I think, a pretty good slot of time to talk about your case study. There you go.
Yes. Hopefully everybody can hear me all right. Yeah, thanks. Dean set the stage with a little bit about the macroeconomic conditions driving towards automation, as well as a little bit about the trends of where automation is heading. We thought it'd be nice now to provide a case study of a real-world example of a client we worked with just a couple of years ago, some of the challenges they were facing, and how we evaluated that automation and ultimately landed at a strategic design that really was going to help catapult their operations moving forward. Wrong way. A little bit of background on this client. This was back in the 90s when this particular initial facility was designed. And back in that time, this was primarily a footwear wholesaler, sending product out to a very limited number of independent stores for the most part. Back in that time, those wholesale orders had a certain profile that drove the design of this particular facility. And those wholesale orders had a large number of lines, a large quantity, lower numbers of orders flowing through that facility. And when you looked at those design requirements, it drove a lot of the concepts you see on this particular layout. Core to this particular facility design was, in the top center, was a large tilt tray sorter with a defined number of chutes and with dual induction on both sides to make sure that product was feeding those chutes on a regular basis. A very good design to be able to batch pick upstream, drive efficiency in that picking operation, but yet then sort that down to store level orders and on out for packing. So pretty traditional design from what you saw back in the day for that type of wholesale activity. Feeding that particular tilt tray sorter was case picking from very narrow aisle deck rack adjacent to it, as well as some pallet rack picking out of the narrow aisle rack so that that product could be brought forward. Just to the left of the tilt tray sorter were a couple pick modules as well, and those were to handle some of the smaller size orders, but also to feed certain residual cases over to that sorter. So when you have leftover quantities of cases going to that sorter, those leftover units have to be put back in place. A lot of times they're put into that pick module and then drawn back out to feed that sorter again. Once those orders were complete, they would then be taken onto the automated seal, print and apply, and out to the line. And again, back in the day, that was a fairly standard design meeting those wholesale needs. But what happened from that time until a couple of years ago was some pretty significant changes in their business and industry overall. In their business, it started out as primarily a footwear wholesaler. They added a lot of SKUs in apparel. There were a significant increase in overall style, color, size SKUs, and it dramatically exploded the number of SKUs they had to manage. And so that variety was out there. But also, like everybody here probably knows, that e-commerce volume really started to kick in. And so they started shifting a lot, less and less wholesale, and the e-commerce volume really started to take off in that facility. Those orders, as we all know, are a lot more complex orders. They're typically a lot more orders, smaller lines and smaller units. That creates a whole unique requirement on that facility that had to be accommodated, and that was putting stress on that particular facility. Some of the very specific kind of challenges that were being felt at that time was heavily around the allocation logic. With a defined number of chutes on that tilt tray sorter, that was constraining the number of orders that could be processed in any given wave. So you're trying to churn through a lot of waves throughout that day to try and keep that volume coming out. Again, was good for a lower number of orders back in the day in wholesale, but was really having a hard time keeping up with the e-commerce volumes. And also the throughput on there with the induction, when the throughput requirements of that particular time was really having a hard time feeding that particular sorter to meet the e-com requirements. In addition, all that pain was actually shifting upstream as well. There were residuals being brought out. They were being put back into the storage areas, and the picking capacity started experiencing some really significant challenges, not only because of the volumes, but because of the multiple picks required of residuals and of vendor cases to try and achieve those targeted volumes. So this whole shift to e-commerce is putting a lot of strain on the sortation and the picking operations. We've touched on residuals a little bit, but the picking side of things as well was that within those modules, there were a lot of dedicated locations. With the SKU proliferation that they saw, there was a lot of energy being put into slotting of those SKUs into dedicated locations. So a lot of maintenance there, and when there weren't SKUs available, there would be shorts on those orders. Dynamic pick faces were introduced at times to try and account for that, to try and change over some of those locations to handle that big variety, but that was creating some challenges on the operation. And full cases were not always full cases, again, because of the residuals out there. So in summary, system was designed for a wildly different profile back in the 90s. That profile had changed. Outdated equipment was also creating challenges with parts and obsolescence. And even when you got into the controls, the communications and some of the controls in that facility, they were just outdated and becoming highly unreliable. Let's see. So what we ended up doing, we ended up engaging with the client and really began to look at the new operational requirements on that particular facility. Again, we looked at their e-commerce profile, projected out for about 5 years, looked at those future state requirements, and began to evaluate alternative technologies to try and drive improvements in that particular operation. What you have here on the screen right now is a zoomed in portion of really the core processing area of the facility. And the next slide will zoom out and kind of give you that big picture. But really what the big shift here was introducing a pocket sorter in place of that tilt tray sorter. Pocket sorters are relatively new, a number of years old now, somewhat limited install base, but seem to be gaining a lot of traction. But you can see that pocket sorter, which is essentially pockets hanging from a overhead trolley system and sorting that out to e-commerce, had a very high throughput rate of 7,500 units per hour to be able to meet that high e-com volume. It had about 100,000 unit buffer there as well to try and accommodate that wide variety of SKU counts and the units needed to meet that throughput. So pocket sorter in place of that tilt tray was a major driver of the change here and was what was really driving a lot of efficiency in operation. We also introduced a 5-aisle shuttle system there to help feed that, not only feed that pocket sorter, those individual units, but also to support some of the other smaller volumes. It was about a 60,000 tote system, about 5 aisles. About 10,000 of those totes were single SKU full totes, and then those totes can also be subdivided in order to drive space efficiency within operation. But that gave us a wide count of SKUs to be able to accommodate in that system. Full case picks were still taking place out there, and those full case picks were either satisfying up on demand or feeding the shuttle system there, and those were actually removing all residual cases out from the rack. And when you remove that, that took care of a lot of the inefficiencies in those pick operations. Once the orders were complete, they would go on to automated dunnage, seal, and apply, as you'd normally see. We introduced a sorter out there on the docks to kind of sort down those wholesale orders down to customer level as well. And there was an auto bagger being introduced as well to try and drive efficiencies, not only in that pack out operation, but also to help with transportation costs. As we looked at the big picture then, this design was developed in a way that allowed them to either install this technology into their existing footprint or to go to a greenfield particular site. What's interesting here is you look at, this was a 5-year plan laid into that existing footprint of space, and not only did this meet all of the future requirements in terms of storage and throughput, but actually gave them about a 50,000 square foot buffer space there because of some of the density improvements that were done. With that pocket sorter leveraging the full vertical of that building, that drove quite a bit of improvement in density in that operation. And then we went to some narrow aisle rack off there to also drive some improved footprint. So overall, we were meeting the 5-year design storage requirements, throughput, and giving them some space back, and giving them the flexibility to either maintain this operation in an existing DC or move on to another facility. So I guess some of the questions come back to how and why do you justify some of this technology, the pocket sorter in particular. Again, if you look at the bottom, it's a fairly newer technology. Back a couple years ago, it was about 25 installs in North America, about 200 worldwide. But we're tending to see this more and more as e-com picks up. It seems to be an area of a high level of interest. But the main requirements around the pocket sorter, one was the operational requirements was a high level of throughput. At 7,500 units per hour, sorting down to pack out stations, not only did that meet the throughput requirements, but drove a very high level of efficiency in that operation by allowing those workers to stay stationary and bringing those goods to that person. There was also that 100,000 unit buffer, so a second requirement was really handling the wide variety of SKUs, but also the number of units needed to be able to cycle through that operation every day. So 100,000 unit buffer there were part of the operational requirements that were there. But when you also looked at some of the financials behind this then, you looked at overall cube utilization and the ability to kind of go vertical with that processing and that staging of that product and tighten up that footprint of space really helped draw down the amount of space required and show good justification through the utilization of space in that facility or the smaller facility if they were going to go to greenfield. The product did hold, this pocket sorter does hold a wide variety of product types as noted on the screen here. Each of these units are held independently, so you can cycle those down to those pack out stations and really feed these e-com orders in the right sequence. There was a dramatic labor reduction. I think the next slide we're going to show you about I think out of a base of around 1,100 total FTEs in that facility, there's about a 400 FTE reduction over the time frame. So really dramatic reduction by keeping those workers stationary and by letting those goods be brought to that person. And it integrates into the existing facility by leveraging that vertical space. Before there was a lot of a wasted cube in that facility. Here by going vertical, they were really able to tighten up that footprint of space. So yeah, when you kind of come into these things, a lot of times it's coming down to can that incremental investment be justified through a reduction in space and the associated savings or through the reduction of labor. The other main component of this design was that 5-aisle shuttle system as we mentioned. Again, about 60,000 totes in there, 10,000 of those single tote SKUs, but then we are able to subdivide totes to try and drive further efficiencies. Again, what's behind this is that density of storage. By going fully vertical and keeping those very tight spacing on those aisles, that footprint came down just a fraction of what it was in those other modules, so that was a very tight density of storage. Very high productivity. These systems often can drive over 600 lines per hour down to an individual stationary. So again, bringing those product to that person, driving that high level of productivity resulted in not only the ability to meet those service level commitments, but also to drive significant reductions in labor. Sequencing of the pick engine, what this was able to do was bring the right product out so that we could feed the pocket sorter or feed live orders. So those two kind of worked in tandem and kind of came together with some nice synergies. And installed systems, this is, as you see out here, very common type solution here across the world. A lot of installs in the US, but more so worldwide. And we're starting to see even evolutions of this, not to be totes captive in aisles, but more with the ability to share those totes across different pick stations, driving further benefits in that. So when we kind of rolled all this up and looked at overall system justification, now the important part here is that each of these areas were independently justified. So we would look at each of these, look at the cost of them, and say, does an incremental spend justify through labor and space savings? But when we rolled that all up, it was a pretty significant capital investment. You were talking about a $44 to $47 million total MHE budget, so a pretty significant spend. But when you looked at that, we were estimating somewhere $20-25 million a year in overall labor reductions, netting out to about $235 million over the 10-year horizon. So a fairly good payback on that kind of incremental spend. As I mentioned, a pretty large direct labor base as we started, about over, I think, 1,100 total FTEs, but we were able to reduce about 400 FTEs at the start and over time frame. So that significant reduction was driving a big part of that direct labor savings and ultimately helping to justify that solution. When you did that, also took a lot of trucks out of the operation, being able to reduce some of the capital spend on that. Order waves before were very big and lumpy with that sorter and the number of stores that had to be waved together. Here, with a little bit more fluid type waving with the pocket sorter and the shuttle, that tended to be a much more smooth flow of orders and keeping the labor force very busy yet not overwhelmed. Residual processing was, for the most part, eliminated by the combination of these technologies. There was an overall warehouse execution system that brought all these components together into an overall solution. And what we're seeing more and more too is where back in the day automation was tied to high levels of ongoing maintenance, nowadays we're finding that these systems are being designed in a way with a very low level of maintenance required. A lot of times shuttles can be swapped out in a matter of a short amount of time, worked offline. So a lot of the systems are now have very low maintenance impacts, even though they're fairly high automation there. And then the bigger thing was that they were now set up to handle a lot of these higher levels of processing requirements, not only current year, but also looking over the next 5 years and all the additional volumes that were anticipated to grow through that time frame. So overall, very good design for them, a lot of good justification, right combination of technology is really key to that. I think with that, Dan?
Yeah. So key takeaways from this discussion is run the math. So automation, although it does pay back many times, Dean and Trevor just did a project recently where our client went into this project saying, we're going to do a highly automated facility. That's what we want. So they did the work, they did the math, they did the designs, the layouts, the labor models, the equipment costing, and it just did not pay out. So, we are advocates for our clients and we want to do what's in their best interest, so we actually recommended a very low-tech solution. But you really need to run the math, and the financials need to be sound enough where the board of directors can scrutinize them and feel good about the decision. So that's one thing our team is very good at doing, is making sure that we run the math. And when automation does justify, we typically can get it approved, funded, and really put on the books and start ordering our equipment. So it's very important that you run the math, you go through the details, the devil is in the details. Also, I would say pick a partner who understands how to integrate all these systems, because these systems do not operate in isolation, okay? Data is fed from other systems, data goes to other systems afterwards, so you really need to have someone who understands the big picture, how to integrate all of these various systems together. Do you need a stronger warehouse management system, or can you put in a warehouse control system that has advanced functionality like a warehouse execution system to support you moving forward? So there's a lot of different things, and you really have to understand the landscape of the different technologies out there. And also, one other thing to think about in automation is typically automation will allow you to reduce your headcount. And some headcount may not be very skilled, and they may be better off in another industry. But I'm sure you have some amazing employees, and these systems out there require some amazing labor to keep them running, to troubleshoot them, to optimize them, and to keep them running at peak levels. So when you think about automation, yes, you may reduce headcount, but it's the headcount that you keep that's very important and very key to sustain your systems over time. And then, of course, one thing our clients on is to ensure you support your system over time, because these systems will erode. You have to continuously have spare parts, you need to service them, preventative maintenance, and you need to keep them up and running, and that's not going to happen by itself. You really need to have a program in place to do that, okay? So that is our presentation for today. Are there any questions from the audience?
Any questions? Anyone? Well, you guys covered it. How about that?
One thing in full transparency, the system that Trevor just reviewed was never installed. The justification, as you saw, was quite compelling. But the board of directors recognized that A, it was a longer-term investment, and the PE firm that owned them wanted to turn the inventory, the firm itself, more quickly, and so they did only short-term improvements to enhance the value, and then sold the company. So, although automation can make a lot of sense, and to us, why not? The bigger picture from their perspective was maybe not, because they wanted to do something different with the company than hang on to it for a protracted period. Sir?
That's right.
Right. And
Absolutely.
so if they want to buy it and own it for 10 years, it'd make a lot of sense. But that wasn't the model they were working from. So the economic environment does matter. It's not simply an engineering and math problem.
Thank you. So you mentioned a lot about the maintenance. I know that just for us personally, we see a lot of the younger generation is very much interested in design and the innovation side. Not much support there as far as maintenance and tech side. We're not seeing the interest. And it's very hard to upkeep, from what I understand, a lot of the new automation.
Well, to Trevor's point, much of the automation actually behaves very well from a reliability perspective. And in terms of mean time to repair, in many cases, to get the piece of equipment back up and running, it's simply a matter of pulling, for instance, a shuttle offline, and the rest of the system can continue to operate, and then you can fix the shuttle in slow time. Now, as it happens, my son just took a job as an automation tech, and he's very mechanical. He can tear apart and fix things. He did not get that from me, but he loves doing that. And what we're seeing is that if folks understand the value, and in case perhaps a college education didn't prepare him well for that, that the opportunity is actually very exciting because you're working with some pretty high-tech equipment. We have one client who put in an auto store. You've probably seen that in front of the building here. And one of their pickers, as the system was being installed, was fascinated by what he saw. He was a high school guy, just basic picker, but was so entranced by what he saw that he sort of picked the brains of the installers as they were doing it, and he's now the maintenance tech for that customer who's since expanded their auto store twice. So although it's complex, for the most part, the maintenance is relatively accessible. And that's one of the enhancements, because for the most part, the companies who are building these systems recognize that what they're building is going to be mission critical to your operation. If it doesn't work, you don't ship, you don't invoice. No money, no job, right? So they've learned that over time, and for the most part, build systems that have a very, very high mean time between failure and a very, very low mean time to repair because of that. So while it's important and it needs to be attended to, it shouldn't be considered a barrier. It just needs to be paid attention to. Does that help? Yeah.
Any other questions?
If you're looking for automation techs, by the way, your local fork truck dealer, their techs can probably repair your automation equipment if they can repair your fork trucks. They're no more complicated.
And then one more announcement, if you want to talk any more about these technologies, we are in the other building, 3879. We're in the far side of the other building. But thank you everyone for your time today, and I hope you learned something. Thank you.
Give a round of applause for Dan, Trevor, and Dean from enVista. They're South Hall, booth 3879. Thanks, guys.